Okay, we're about to have a really intense discussion. This is about how architecture is changing. Specifically, how does machine learning change what we think about when we think about architecture? So join us. Welcome to the Azure Enablement Show, where we'll be discussing the challenges you and our other tech-savvy customers have encountered. Together, we'll be talking with experts to find out how they think about these problems, recommended tools and best practices, and tips they've learned from years of experience that you can use. So today on the Azure Enablement Show, we're doing something we've never done before. We're going to take our script and we are going to simply rip it up because we want to talk today about architecture. And architecture is a discussion. Hey, so we're back with Uli and Eric talking about one last context about ways that architecture is changing. And the one that I was hoping we'd talk about is stuff around machine learning and what I've heard called software architecture 2.0. But I think we should do what we like to do, which is level setting, get just a little bit of context of what that means. Uli, can you say a little bit about what we're talking about in this episode?
Yeah, perfect. So first of all, let's define what machine learning models are. At the end of the day, there are techniques to encode statistics or mathematical models and utilize data to effectively evaluate decisions. And that's really, in a nutshell, what it is when you really boil it down. And the transition from software 1.0, which is imperative code, somebody typed in if then else statements and so forth, to software 2.0 effectively says that parts or all of the application is being replaced from imperative code, C#, Java, Python, whatever it is, to these models. Actually, funnily enough, the models are built in Python, or mostly. And the idea is that you take fixed functionality, because once you write a piece of code, it doesn't change. It doesn't change its behavior, and replace it with a model that evaluates based upon the data it sees, the data it gets, and data it uses, and evaluates decisions. And I have a great example. One of the environments that we're using for collaboration a lot actually replaced 150,000 lines of C++ code, which was effectively a set of policies that determined if I connect to a backend, what is the jitter? What's the network look like? I have various network connections I could pick, and based upon this very fixed set of code, I will make a decision. Now, the problem is that this jitter and everything else continues to change with 5G and whatever else you might do, and we always had to update the code to do new things. With the model, it actually is the data that informs the decision. And it really is a fundamental change. And when you think about machine learning AI, today, most of this is in the context outside of an application. So I do risk analysis or fraud detection, those kind of things. But there are services that I call and bring in. This example that I used with this collaboration environment is now part of the application. So you have imperative code that does certain things, and you have models that do certain things, and they're packaged as one. And that, I think, is the real meaning of software 2.0, where you replace on the one side imperative code with models, and on the other side, you bring the models closer into the application context and make it as one thing, which then has its own challenges that we talked about before. And Eric has some great ideas in terms of what you need to think about here.
Yeah, the way I interpret what Uli said and the way I break it down for myself is that there's deterministic code and there's probabilistic code. And deterministic code says it does it does the same thing on day one. If you don't change it, it'll do the same thing on day 365. The models, however, operate in realms of probabilities, which means the way that a model is trained based on a data set, it may operate at 86% accuracy on day one. And if you leave it like locking a puppy in a closet, it may deteriorate over time and become super, super low confidence, right? Maybe a little dark there, but that's the essence of what you're doing. You can't lock these things in closets and assume that they're going to operate. So there are a couple of things that we need to look out for as architects when we do these things that Uli mentioned, which is to inculcate models or bring them into the application and put them in the critical path of functionality. We have to continually be able to monitor and watch them not from an input output. I'm calling this module, I'm calling this service, and is there a dial tone or did it reply back and I'm good. It's more of what did it tell me, and is what it told me confident. Do I have a high degree of confidence of the quality of what it told me? If I don't, it's equivalent to an application down situation, because I could be denying people loans or airplane seats or tickets or some other crucial element of functionality. So I think that those are the things as application architects we need to worry about. They're not just microservice architectural components to be included, and if they're responding, everything's good. We need to look at the quality of what they're telling us.
And again, I would add two specific examples on this one. One is called model drift, where the model is drifting based upon the data it gets fed into the wrong realm. And then I would call it almost, you need to, where we today have a virus scanner for files, we need a virus scanner for data, where the data that is getting fed, if it's maliciously done, then obviously the AI model might do malicious or stupid things based upon the data that get fed. So if you can control the data, that's great. If you get input from random sources, you need to make sure that the data is accurate, doesn't do bad things, and so forth. There was a very famous example where Microsoft put up a bot that was very, very nice from a functionality perspective, but people figured out how to make it do hateful things because they were feeding it the wrong data. So part of this is model drift, really deeply understanding the data that's being used to feed and drive the model, new considerations that come up with software tool.
So what's interesting to me is there's echoes from our first discussion together in which we were talking about what reliability or resilience means. And reliability is not just availability or latency, but it's also correctness to a certain, that's
Quality.
the thing. Yep. And I'm also aware, Uli, when you talk about a virus scanner, it's not always malevolent things, it can also be absence. So we know very clearly that there's some real problems around models that are fed incomplete data that aren't including a really good sample set from different races, classes, or stuff just for humans, right? Like it's very possible to inadvertently skew the data by not feeding it a really good representation of what you care about, and as a result, stuff goes on. It looks like, Eric,
Actually, this topic is becoming big because my brain is going all over. There are entire fields of study, from adversarial machine learning to our own work in responsible AI we should probably discuss. Might make for a great future topic for us to dive in on and talk to people about how we do these types of things.
Okay, so let me bring it back to architecture, and we'll cut this down because it seems like we could go definitely in a thing. It seems to me like one of the key things that is a change when we're thinking about software architecture 2.0 is our relationship and our understanding of the input. There's like two flavors of input, right? There's the input to the model and there's the input coming in to be evaluated by the model. But that for sure is one way that architecture is changing around this, is our cognizance of that has to be at a much higher, we have to turn that dial way up. Are there any other architectural things that happen as a result of this situation that we can say as advice as architects, like pay attention to this, or here's a big change that you should be aware of?
So Eric mentioned it, and that's the big one, which is we're moving from deterministic behavior, it does the same thing every time, to dynamic behavior, which is relative. So it tells you, here's what I think it is, and here's my probability of what I believe is right. And therefore, the person that invokes the model and gets the results back needs to determine, what do I do with this result? Because it's not deterministic. And that is certainly a great opportunity because the system does behave dynamically, but it's also a burden. So part of what you need to think about is, if you have a safety concerned system, like for example, autonomous driving, can you use models in the driving decisions? Most likely not, but you can use the models for perception management. So meaning reading the camera and understanding what's there. And the system will give you probability that this is a concrete wall, and then you need to make decision, well, if it's a concrete wall with this higher probability, I will stop. But that has to happen every time. And so you need to really think through how you use deterministic code and these models and compose them together for best effect.
as a last point for me, in addition to what Uli said, don't underestimate the technical architecture and process architecture required to keep these models up to date, to keep them trained, and to keep them deployed, both in the cloud and at the edge. It can't be an afterthought. Start planning that as soon as somebody says, hey, this is really in the realm of a model. There's a whole architecture around ML ops, we call it here at Microsoft, about doing all of the lifecycle management and maintenance around training, redeployment of those models. And that's super important to think about.
That's a fabulous place for us to end up this conversation. I know we have more topics to talk about. I'm hoping you'll join me for some of those too.
Absolutely. Love to.
You got it.
Okay, that was a really cool set of conversations. I hope you get a chance to watch those episodes. We're going to move on to another topic here on Armchair Architects as part of the Azure Enablement Show.